Hi, so welcome to another video. So today I'm going to look at functional groups within line diagrams. So identifying the different functional groups that are present within the molecule. So let's draw up some molecules and we'll get started. So let's have a look at these three molecules here. So we've got the line diagram. So remember, when you have a line diagram, we're not drawing in the hydrogens that are attached to carbons. We've got hydrogens that are drawn into other atoms. So if they're drawn to an oxygen, they're attached. If they're on a nitrogen, they're attached. But if they're on a carbon, then we don't draw them in. So looking first at this blue one here. So we can see that we've got our carbon backbone. We've got an OH group here. So that's one functional group. We've got two lines here. That one's another functional group. And then depending whether or not you've covered this functional group here in your course, there's a third one. So this one here, an OH that's bonded to some sort of carbon group, is an alcohol. This one here, where we've got two lines, is an alkene. And this one here is a benzene. So in chemistry for living systems, if you're at the beginning of the subject, we haven't specifically talked about benzene yet, but towards the end of the subject, we will talk more about benzene and benzene reactivity. So we've got alcohol and an alkene. We've got a lot of alkane functional groups in there, but we're not identifying alkanes. We're just identifying alkenes, alkynes, alcohols, carboxylic acids, and the major functional groups. So if we move across to this greenish coloured compound, you can see we've got a 5-membered ring and we've got a 4-membered ring fused to it. We've got a chlorine coming off the bottom, and then we've got this functional group coming off the top here. So a chlorine group, we could call it a chlorosubstituent or a haloalkane. Or chloroalkane. So there's a few different words that we can use, but it's the halogen that we're using is a chlorine in this one. So chloroalkane's a pretty good description of it. So this other functional group here, so it's got a nitrogen in it and it's got a double bonded to an oxygen. So you can see the two bonds going to the oxygen and the nitrogen coming directly off that carbon that the double bonded oxygen is coming off. We call this double bonded oxygen a carbonyl. So we've got a carbonyl and an NH2. Now there's two nitrogen functional groups. So we've got the amide and the amine. The amide is the one that has the oxygen on the carbon next to it. So this one is an amide. An amide. So the one with the D has got the oxygen. So moving to this bottom one here, there's quite a lot of functional groups in here. So we've got one here, 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 and here. So they're all oxygen containing functional groups, so they stick out quite easy. So if we start from the end and work our way across, if we look at this one here, this one's a tricky one. So we've got a carbonyl, so a carbon that's double bonded to an oxygen, and the carbonyl containing functional groups, we've got an alkene. No, we don't have an alkene. So the carbonyl functional groups we have are a ketone, we have an aldehyde, and we have a carboxylic acid. Okay, so a ketone is when you have a carbonyl that's in between two carbons. An aldehyde is where you have a carbonyl that's on the end of the chain and a hydrogen coming off it. And a carboxylic acid is when you have a carbonyl and an OH. So similar to the alcohol functional group coming off that same carbon that the carbonyl is coming off. Okay, and also another one is an ester. So an ester is when you have a carbonyl with an oxygen coming off the same carbon, so similar to an alcohol, but instead of the hydrogen, you have another carbon that's attached. Okay, and if you look in the description below, there's the link to the functional groups videos. So this one here, we've got a carbonyl. It's on the end of the chain, so it's not likely to be a ketone. It's likely to be an aldehyde. And so just checking, remember an aldehyde is a carbonyl with a hydrogen coming off it. So if we look at this carbon here, remember carbon makes 4 bonds. We've got 1, 2, 3. So there's actually a 4th bond that hasn't been drawn in because it's a line diagram. You don't draw it in, but there's a hydrogen coming off that carbonyl there, and that is an aldehyde. Okay, moving along, we have another functional group here. So you may not have covered this one. This is an ether. So an ether is when you have an oxygen that's in between 2 carbons. So those carbons are just normal carbons. Okay, so there's no other functional groups attached to it, but it's in between 2 carbons. So another one here, we've got a carbon with no other functional groups attached, and then we have an OH. So this is similar to this one up here, a carbon with an OH. So it's also an alcohol. Down here, so we've got 2 more, so we'll start from the bottom. So this one is a carbonyl, and we've got a carbon and no other functional groups attached to those carbons. So this one is a ketone. And the last one we have here, so we've got a carbonyl, and then we've got an O, and then we've got another carbon group coming off. So this one, out of the 3 that we've talked about in the previous video, it's not a ketone because we've got another functional group next to it. It's not an aldehyde because there's no hydrogens. It's not a carboxylic acid because a carboxylic acid would look like this. Remember, it's got an OH coming off it and then some sort of carbon chain. So remember the R means a carbon chain or carbon group. So whatever that may be. So you're looking for this for a carboxylic acid. And the last one here is an ester. So this one's actually an ester. So you've got your carbonyl, and then you've got an oxygen that's bonded to another carbon group. Okay, so that's a couple of different functional groups there. The other ones that aren't in these examples would be an alkyne. So that's a triple bond that you might see in a molecule. So if you see like a triple bond there, that would be an alkyne. We've got a ketone, aldehyde. We've drawn the carboxylic acid. We've got the ester, the ether. They're our main oxygen ones, and our alcohol. Then we've got our amide. So another one is an amine. So let's draw an amine off here. So we've got 1, 2, 3. That's our 4th bond, and an NH2. So this would be an amine. So see the difference between an amide and an amine in a line diagram? So we've drawn in the hydrogens because it's attached to an atom that's not carbon. So we draw it in, so nitrogens, oxygens. Here we have it attached to a carbon, and there's no other functional groups attached to that carbon. So with the amide, we have the carbonyl that's attached. So there are 2 main nitrogen-containing functional groups. We've got a haloalkane. Another halogen that you might have is a fluorine, a bromine, or an iodine are fairly common. So those ones in the place of chlorine. Okay, so that's line diagrams and identifying some basic functional groups. Thank you.